All right, so now we're going to move on to logarithmic equations. So there are three types of log equations that you guys will see. There's type 1, where there's a log on one side set to a number or expression on the other side of the equal sign. Um, Type 2 is where there's one log expression on both sides of the equal sign. So let me just write some examples. So an example of type 1 would be log of 5 of x equals 3. So there's just one log and it's set to a number. And I'm going to do this in a different color. And so type 2, an example could possibly be log of 3 of 3x plus 2 equals log of 3 of 15. So there's one log on each side. There's only one expression on each side. And then the third type you might see could be log base 2 of 15 minus 3 equals log base 2 of, 5x. So here, there's logs on both sides, but there's this 3 here that we kind of have to deal with, that kind of throws a wrench in things. So these are the three types, and we're going to go over examples of each of them. So let's look at type 1, where log is on one side and it's set equal to a number or expression on the other side. So when we have this kind of problem, we want to rewrite this as an exponential equation. And the way we do that, so if you recall from previous videos, if we have something in this form, we can rewrite it as b to the power of x equals L. So b to the x equals L. So this is our b is 6. So we can do 6 to the second power, 6 to the second power equals whatever's in these parentheses. Right? And then now we know how to solve this, and this is a 6. Not a b, this is a 6. So 6 squared is just 36. Now this just becomes a linear equation. So you want to get all the numbers on one side, all the variables on the other, and then solve for x using inverse operations. We get x equals 4. So log base 6 of 4, I'm just checking my work here. This should equal 2. So log base 6, this would be 16 plus 20 equals 2. And turns out this is correct. 6 squared equals 36. 6 squared equals 36. Okay, problem type 2, we have logs on both sides. So we have one log equal to another log. So it turns out that if the log and the bases are the same, so this log 3 equals this log 3, these quantities also have to be equal to each other. So x squared plus 3x has to equal 5x plus 8. Okay, so now how do we solve this? So remember, this highest exponent, or the degree, would be 2, which means there should be possibly 2 solutions. So when there are 2 solutions, 9 times out of 10, you can factor. You can use factoring to solve. You might use a square root in some occasions, but you can always factor. So we want whenever we have to factor, we want to get one side equal to 0. So we're going to go ahead and subtract both of these terms. And we get x squared minus 2x minus 8. The 8 can't subtract from anything, so this is like a plus 0, so we're just subtracting 8. All right, so now how do we solve this? So we need to factor, which means we need to find two numbers that multiply to negative 8 and add to negative 2. So those two numbers turn out to be 4 and 2, or negative 4 and 2. Negative 4 times 2 is negative 8. Negative 4 plus 2 is negative 2. So, and then we have two numbers. This is a number, and this is another number, that when I multiply those numbers, I get 0. So x minus 4 equals 0, or x plus 2 equals 0. One of them has to be 0 because they're multiplying by each other to equal 0. So that would imply that x equals 4 or x equals negative 2. So these would be our solutions. And you can plug them back in and check them because sometimes they may not work. For example, if we plug in negative 2, we to the right side of this equation, so we'll get log base 3 of 5 times negative 2 plus 8. This becomes log base 3 of negative 10 plus 8, or log base 3 of negative 2. Log base 3, so I'm going to come over here because I don't have any space. Log base 3 of negative 2. This is asking 3 to what power will give me negative 2. It doesn't matter what I put here. I could put negative numbers, I could put positive numbers, I could put fractions. I will never get a negative answer. So it turns out that this answer doesn't work. 4 does work, but I'm going to let you check that for yourself. So be sure to check your answers because sometimes Alex will ask you for the answer, and if you put both, you'll be considered wrong. So just a reminder, check for extraneous solutions. All right, so now we're on type 3 problems where there are logs of both sides, but we have added terms. So we have a log on this side, we have a log on this side, but we have this 1 here, which kind of complicates things. So these problems are a little difficult because you kind of have, there's no set way. I mean, the idea is to, one, get all the logs on one side. So we're going to do that first. So to do that, I need to add this, everything to the right of this minus sign. So log of x plus 2 to both sides. These two things cancel out. You get log of x plus 5 plus log of x plus 2 equals 1. So get the logs on one side. And then now we can combine everything on the right side using one of the properties that we learned in the last video. So we can use the product property, which says when we add two logarithms, we multiply the quantities inside. So we're going to multiply x plus 5 times x plus 2. And if we do that, so we have to distribute or FOIL or whatever you call it, you'll get x squared plus 7x plus 10 equals 1. All right, so now after some manipulation and working with it, we have a type 1 problem. So if you look back, type 1 is where there's a log on one side is equal to a number. So we take this base, which if you don't see a base, it's 10, raised to this power, and we set it equal to whatever's in the parentheses, the quantity in the parentheses. So now we need to solve this. Well, again, we have a degree 2 polynomial on the right side, so there are possibly two solutions, which means we can factor in order to solve. So let's go ahead and get one side equal to 0. Get 0 equals x squared plus 7x. These two things cancel out. And now the factoring method we would have to use would be greatest common factor. And the greatest common factor between x squared and 7x is just x. So again, we have two quantities, 1, 2, set equal to 0. So that means either x equals 0 or x plus 7 equals 0. So x equals 0 or x equals negative 7. And if we plug this in, negative 7 won't work. So x is equal to 0. And so if you were to check this, log of 5 should be the same thing as 1 minus log of 2. So if I plug in 0 for x, so if I plug in 0 for x, I should get the same thing. For extra credit, you can create a type 3 log equation, so that's like the one I just did, and solve it. Make sure it works. Don't just write anything.